Let's start with the exercise questions. First question is, the amount of charge passed in time t through some cross section of wire is given by this equation. We need to find the dimensional formula for ABC, and if numerical values of ABC are given, then find the value of current at t equal to 5 seconds. So this is the first one. So first of all, Q of t is equal to AT square plus BT plus C. Now we know that individually all of them must have same units, okay, same dimensions. So AT square must have the dimension of Q. So A will be Q over T square, which will be now Q has dimension of current into time. So current and time is T square. So it will give us I over T. So the dimension will be I T minus 1. Similarly for BT, so B will be Q over T, I T over T, that is only I. Then the dimension for Q equal to C will be same as that of current. So C will have the dimension of IT. So these are the dimensions, individual dimensions. Finally, we need to find the current. So current is given by rate of flow of charge dq by dt. So d over dt, and we need to differentiate this. So after differentiation, current will be 280 plus B. So 2 into 5 plus 5, we will get and this is into 5 plus 3, so this will give us 53 amperes. So current will be 53 amperes. In the second question, electron gun emits some electrons per second. We need to find the electric current. So this is the second one. So number of electrons per second is 2 into 10 to the power 16 electrons per second. Charge passing per second, will be 2 into 10 to the power 16 into each electron has this much charge, so this coulomb per second. So this will be our current. Current is charge passing per second, so current will come out to be 3.2 into 10 to the power minus 6 amperes or coulomb per second. Oh, this is minus 3, 16 and 19, minus 3 will remain. In question 3, the electric current existing in a discharge tube is given. How much charge is transferred across a cross section of tube in 5 minutes? So this is the third one. So first of all, current is 2 microampere, time is 5 minutes or 5 into 60 seconds. Charge will be current into time, 2 into 10 to the power minus 6 into 5 into 60, which will give us 6 into 10 to the power minus 4 coulombs. This will be the charge. In question 4, the current through a wire is given by this equation. We need to find the charge crossed through a section of wire in 10 seconds. So this is the fourth one. First of all, equation is this: t 10 second, I naught 10 ampere, alpha 4 ampere per second. So charges can be founded by this equation: 0 to 2, 0 to t time second. So I naught plus alpha t into dt. So we can write it individually: 0 to t I naught dt plus 0 to t alpha t, let's write alpha outside because it is a constant, t dt, and we can also write I naught outside because I naught is a constant. So it can be written like this. So it's quite simple: I naught, this will become t, plus alpha, this will become t square over 2. So just put the values. You will obtain 10 into 10 plus 4 into 10 into 10 over 2, which will give us 300 coulomb. So charge will be 300 coulomb. So we have integrated this because the current was depending on the time, so we needed to integrate this. In question 5, current of 1 ampere exists in copper wire of cross section 1 mm square. Assuming 1 free electron per atom, we need to calculate the drift speed of free electrons in the wire. So this is the fifth one. First of all, what we have: current is 1 ampere, area is 1 mm square, that is 1 into 10 to the power minus 6 meter square. Then density of copper is 9000 kilogram per meter cube. So now molecular mass, in 1 mole we have Avogadro number of electrons. So it is given that number of atoms is number of electrons, each atom give 1 electron, so the number of electrons will be equal to the number of atoms. So n will be number of electrons over per unit volume. So number of electrons will be equal to n naught into area into density into mass into length. So this will give us n naught into density over mass. So from this, n will be equal to 6.022 into 10 to the power 23 Avogadro number. Density is 9000, mass 63.5 into 10 to the power minus 3. Because it is in grams, so we need to write it in kg. So from now, this current will be Vd NVD A into E. So Vd will be, drift velocity will be current over NA E. So 1 over 6 into 10 to the power 23 into 9000 over 63 is there, so we can write it upstairs: 63.5 into 10 to the power minus 3 into 10 to the power minus 6 into 1.6 into 10 to the power minus 19. So from after solving all this, we will get drift velocity equal to 0.074 into 10 to the power minus 3 meter per second, or 0.074 millimeter per second. In question 6, wire of length 1 meter and radius 0.1 mm is given, radius is resistance is 100 ohm. We need to find the resistivity. Sixth one, length 1 meter, resistance 100 ohm, radius 0.1 mm or 0.1 into 10 to the power minus 3 meters. Now resistance is resistivity into length over area. So resistivity will be, do not get confused with the symbol, okay, I use this for density, now I am using this for resistivity. So resistivity will be R into A over L. Now area will be pi r square, 3.14 into 0.1 into 10 to the power minus 3 whole square. So resistivity will be 100 or 10 to the power 2 into 3.14 into 0.1 into 0.1 into 10 to the power minus 6 over length is 1. So after solving this, resistivity will come out to be 3.14 into 10 to the power minus 6 ohm meter. Unit of resistivity is ohm meter. In 7th question, uniform wire of resistance 100 ohm is melted and recast in a wire of length double that of original. So what would be the resistance of the wire? So this is the 7th one. So new length is twice of the original length. Now as the volume remains same, so area into length and new area and new length, so volume will remain same. So area into length equal to A dash and L dash is 12. So from this A dash new area will be A over 2. So L dash is twice of L and A dash is A over 2. So R will be rho L by A and R dash will be rho L dash over A dash, that is rho 2L over A over 2. So R dash will be 4 rho L over A, that is R dash will be 4 times of the original resistance. So new resistance will be 4 times of the original resistance. So R dash will be 4 into 100, that is 400 ohms. In question 8, we need to consider a wire of length 4 meter with some cross sectional area and current. Now if each cubic meter of material contains some electrons, we need to find average time taken by electron to cross the length of the wire. So this is the 8th one. Length is 4 meter, area is 1 mm square, that is 1 into 10 to the power minus 6 meter square. Current is 2 ampere and charge per unit volume is 10 to the power 29 total charges, and time we need to find. So we know that current equal to NEA VD into E and NAVD into E. So from this formula, VD will be I over NA NE into A. So let's put the values. So VD will be 1 over 8000. Now time is length over trip velocity, because velocity is length over time. So 4 over 1 by 8000. So it will be 4 into 8000. So time will be 32,000 second, or 3.2 into 10 to the power 4 second. In question 9, what length of copper wire of cross section area 0.01 mm square will be needed to prepare a resistance of 1 kilo ohm? Resistivity of copper is given. So this is the ninth one. So here resistivity of copper is 1.7 into 10 to the power minus 8 ohm meter. Area 0.01 mm square, or 0.01 into 10 to the power minus 6 meter square. Resistance is 1 kilo ohm, that is 1000 ohms. We know that resistance is rho L by A. So L will be RA over rho. So L will be 10 to the power 3 into 10 to the power minus 6, 1. Area is how much? Area is 0.01 into 10 to the power minus 6, and then over resistivity, which is 1.7 into 10 to the power minus 8. So after solving this, we will get approximately 0.58 into 10 to the power 3 meters. So length will be approximately 0.6 kilometers.